Alrighty, ladies and gentlemen, happy Monday to ya. Can you hear me okay? Hopefully. Alright, so we spent some time over the weekend thinking about the pancake problem. We solved it just fine in the small case, but the large case was kicking our butt. Clearly, Dijkstra's or just general graph traversal is not going to fly for this large data set. So if you'll recall that Dijkstra's algorithm runs in big O of v squared, where v is the number of actual nodes you have to visit. The test case that was giving us trouble on the big pancake, it had 1,000 pancakes in it and had a flipper of size 2. So what that basically means is that you've got how many possible states of pancakes in that one? Well, what's 2 to the 1,000? Absurd large. So if you're running in that time scale, you're just going to die a horrible death. So I cheated and looked at the analysis. Google for past questions gives you an analysis. I will go ahead and link this in the Twitch chat as well as in, not that anyone's watching my stream right now, but I'll get you in the stream chat as well as in the YouTube description. So anyways, here's what this says. Yeah, you can do normal breadth first search for the small data sets. For the large data set, that's just never going to fly. There's a greedy algorithm you can do, which depends on 2 facts. I'll let you read this, but here's the basic thing. Fact number 1 is that these flips are commutative, meaning that if you flip one thing, it doesn't matter what order you flip it. That flip, it's always the same. So if you flip A and then B, or B and then A, the result is always the same. The other thing is that the furthest left pancake, there's literally only one flip that can affect the furthest left pancake, and that's, flipping over there. So if you need to flip the furthest left, flip opportunity based on that furthest left pancake. Well, if you don't flip that, then let's talk about the rest of the flips that could affect the second pancake. Well, either the first flip could affect it, or the flip just to the right of it. So I'm going to hurry and implement this greedy algorithm and see where we're at. Now, the good news is that we already have tests written, so all of this changing should be just fine and dandy. Now, I think I've got my editor set up, yep, so that you can see the code and see my picture. No occlusion this time. If there are problems, please let me know. So we're currently using Edgar to run Dijkstra. I'm going to go ahead and draw the best way to change this. What's calling Edgar's get nearest, where's the method? Get shortest path. Okay, this one should be at the top. Who's calling that? Oh, that's your vector. So Control-Alt-H will bring up my call hierarchy. I'm going to pull this up really quick. And the driver is running it. What did you do? Okay, so we're going Edgar.get shortest path. So I'm probably just going to plug in something that's not Edgar right now. So let's make a new class right next to Edgar called greedy algorithm. Why the heck not? New class. We're going to name this greedy direct solution. Why not? Okay, and it's going to have a method that is public int get shortest path, and it is going to take in a pancake p. Okay, so what does this need to do? So what we're going to do is take a look at the whole line of pancakes. See if we need to flip the first one, the furthest left one. If so, flip it. Then see, flip it, and its neighbors, right, depending on the size of the flipper. And then check the next pancake. So I'm really upset that I didn't actually think of this direct solution earlier. Let's hurry and code it up. Okay. So, let's just do this. For in time equals 0. Yes, I know. No one likes doing a for loop over an array, but here we are. I is less than p dot get pancakes dot length. Let's just say length. If you just have a length method, just add that in there really quick. Public length return pancakes dot. Great. Where are we at? Greedy direct solution. P dot length, and then we'll shoot p plus plus. Okay, and we'll say if. Let's just get pancakes right now. So boolean array pancakes is equal to p dot get pancakes or rate Yeah, I know my naming's not great on this, but that's fine. So if cakes of I, and if cakes of I is false, we're going to call flip at I. Flip. We're just going to call flip right now. We're going to call it, we're passing I. Okay? We're going to create flip. And this should probably happen on the pancakes. Let's, okay, here's what's going on. I want to clone pancake P. And then I'm going to actually mutate this pancake right here. So I'm going to say pancake clone is equal to P dot clone dot pancake dot from string. No, new pancake. I can't even call that, can I? I'll just call it P dot clone. Okay, so I'll add that over in P. P dot clone pancake. Let's create a method over here. So, return new pancake, pancakes, and flip size. Now, is that going to pass in? Dang it. The string. So I almost want to. Okay, private static. So I've got from string. I've got create pancakes. Huh. Oh, that creates the. Gotcha. Okay, I'll just make an actual method here that just does this, right? So we'll say boolean array clone cakes is equal to arrays dot copy of pancakes pancakes dot length. Make it a flag. We'll try it. And then we will say return new pancake clone cakes and flip size. Okay. Reasonable. Should probably write a test to handle that really quick. Let's just try this. Test public void test clone pancake is equal to pancake. Let's just use that one. I think not. Alright. We'll say assert equals expected is P dot clone pancake. Let's just make sure that looks reasonable. Okay, that passes. And then let's try a little bit. Make sure we're not shallowing this. Just a quick deep clone. We don't need to do that anymore. We want to say P dot clone pancake dot. I don't have the flip method yet, but let's add a flip method on pancake. Where is my greedy? Let's just call clone dot flip I. Flip I. What I want to do is say 4. And I equal index is equal to I. Index plus plus. Index is less than. Alright, fine. Okay, so rename this index. For I is equal to 0. I is less than flipper size. I plus plus. We will say that pancakes of I plus index, index plus I is equal to not pancakes of index plus I. Great. So that should flip exactly flipper size pancakes though. Right. So let's just see if that works. Okay, we're gonna ignore you for a minute, but back in planting test. We'll call pancake clone. For that. Apparently I can never type pancake correctly. That's okay. I'm gonna say clone dot flip at 0. A couple things. We want to assert these are not equal. Assert not equals. Okay. And then we want to say assert equals clone. Actually, we'll do pancake dot from string. What we expect is this initial string, except we want those first 3 flips. That's going to be minus, minus, plus. Okay. And flipper size. Holy crap! I don't want a flipper size 3. I want a flipper size 3, not 8. And then we want that to be clone. Okay, so let's try that. Okay, deep clone not working. Values should be different. Actual. Okay, so we call. Oh, that's what we're passing in. Clone. We don't want. Clone. Let's try that. Better. Okay, so that's working exactly as we expected. Lovely. Okay, so we can call flip over here. So I is it's going to be I plus plus. I plus plus. Okay. What we need to do is say flip count is equal to 0. If we're going to we say flip count plus plus. Okay, and then if we get to the end of that, it'll be if clone dot is happy, return flip count, otherwise return -1. Cool, that was really fast. Let's see if this actually flies. So let's see, we get the clone of P, right? And we get the clone's pancakes. Call clone, pancake pancakes, that's fine. Okay, flip count is now, flip count is 0. We go through the whole list of cakes. If we need to make it happy, we flip it, and then we'll just move on. Okay, now here's the thing, we can't go to p.length. We need to go to p.length minus flipper size, is that right? Minus p dot flipper size? Flipper size? I don't have a method for that, but let's make one, because I want one. Return. Yeah, that should do the trick. So we get the length minus flipper size now. The length is 5. Flipper size is 4. We want to run this on the first pancake and the second pancake, right? So we'll run it on the first. And then p.length is 5 minus 4 is 1. Yes, 100 tokens. So that actually looks like that should do the trick. Okay, so let's just hurry and replace some of our tests. The Edgar test. Let's just copy all of this actually. We're going to make a new test, which is going to be the greedy direct solution test. And we're straight up copying these over. And changing the test case. You guys hear me alright? Not the like, no one's watching, but if you can't hear me alright, holla at me and I'll speak up. Okay, that needs to be in the test source folder. So I'll finish that. We're just going to paste literally all of this, and we're going to control find Edgar, and replace with a greedy direct solution. Now, we're constructing all of our Edgars with pancakes. Yeah, so you're going to be grumpy, and I don't need to pass in P, so let's just stop passing in P. Okay, see what we do? And honestly, we don't even need to instantiate it. Okay, unresolved compilation problems. My favorite kind of compilation problem. Okay, so you all appear to be, oh dear. Alright, so control shift F that. Okay. Okay, simple case not working. Expected 3 plus -1. Okay, so given this, yeah, there's definitely a way to do this. So what is going on here? Let's debug this guy, shall we? So I hit Control 4 to debug, so I set that up as my key. This is not lovely, but it'll be fine. Okay, so we get the pancake, call the solution, let's call shortest path. So we clone the pancake, that looks like that worked.
Two just got up.
Takes, yeah, false, false, true, false, true, true, false, yeah, that's right. Okay, we're at 0. Yeah, so we're gonna flip that. Flip, okay, so let's look at clones pancakes real quick. Okay, so now that's true, 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 false, true, true, false. Yeah, that looks lovely. Okay, you're good, you're good, you're good. Okay, I'm on what? I'm on 4 now? Yep. So that's gonna be false, so I'm gonna flip that. Okay, so now what do I got? True. Okay, so oh, I'm going too many. You were right. I needed to go one more. Okay, that should pass. Nope, let's try that again. Nope. Let's try this test. Why are you failing? Oh, yeah, you're supposed to work. Test wicked large. Yeah, this thing I added at the end. This would have never finished back in the day. But now that's working, and I don't know what that's supposed to be, so I'm just gonna...
There is a way to get it.
So, distance. Let's see what it is. Okay, so it's 500, and I'm actually going to call that probably correct. I think that is probably accurate. Okay, so I'm passing all the tests we had originally, so I'm going to go ahead and replace in my driver, my main method, instead of using an Edgar. I'm actually going to make greedy direct. I'm just going to make that static. I'll mix that because I'm not keeping any state here. So we're not going to have to instantiate any of this. So if we go back to our test, I'm just going to replace all of those. Completely unnecessary to do so, but kind of feel like it. Okay, and make sure that still passes, because that's how we do. Yeah, of course we passed. So here in my driver, I'm just going to say result is equal to gradient direct solution. Oh, import that. That'll get shortest path. Okay, I think that should do the trick. So we're going to run this. Okay, I'm going to try to solve the small data set. Nice small. Sure, I think I already downloaded that once. It's fine. Now, by all means, I should just actually write the file input and output into my code, because that'll make my life better, but we're not doing that yet. Maybe in the next one. There it is, there's small one out. Okay, so let's, here we go. Oh, bother, wrong one. Oh no, we're stuck. Oh dear, where'd we go? Oh, it's gone forever. There we go. Oh, no stuff, okay. Choose that. Let's go to my desktop. Name modified. Small it out, 319, that's today. Okay, let's open that. Let's submit it. And that's correct, okay. So we'll try to solve large, and we'll download that. I'm gonna do this the same hard way we did before. Okay, so we copied that. We're gonna go ahead and close this. We're gonna run that. We're gonna run this. Okay. We look happy. That was very fast compared to last time, which was very slow. Copying that. We'll do it in Notepad so I don't lose my place. I'll save as. We'll go to my desktop. We'll say large dot out. Okay. Now we're gonna choose file. Desktop. Large dot out. Bingo. And we're gonna submit that. And we got correct on large as well. So that is a solution to the pancake flipper. There is a direct solution that's much faster and easier than Dijkstra's. So now we know. Did you know that? All right, great. So we're going to go ahead and stop this video here and start a new one in just 1 minute. So give me 1 minute to switch problems. Cool. Good job, y'all. I will put this code on GitHub. It's just not up yet. So I'll get that up soon.